Okay, Bismillahirrahmanirrahim. I hope you can hear me. Okay, basically, when we learn about this fluid statics, okay, this is from chapter number 2 or chapter number 3, if I'm not mistaken, about the fluid statics, right? Right? You learn about the manometer, and then you learn about this pressure inside a tank or a container, something like this. Then what happened is that if you still can recall, okay, if you can recall, if you have a tank fill up with water or any kind of fluid, and what happens is that the pressure will get higher, right? Pressure will increase, right? Pressure become higher as you go deeper. Okay, pressure is equal to rho g h, right? Or you can also put it gamma h, specific weight times the depth or height of this particular water, right? That is the basic of it. Then if you want to know about the force due to this particular pressure, then what happened, you know that uh, uh, pressure is actually force over area, right? So in this case, F is equal to P times the area. And you can further expand this part into rho GH times the area, or gamma H times the area. Area of your interest. It could be here. Oops, sorry. Where was it? Okay. The area of interest could be here or here or down here. It's up to you. Okay. That's the basic. I hope you can understand this simple theory. Okay. The principle of pressure. Okay. Then if let's say you have a ball or you have something, here I have a shape of a circle, right? I put it inside this water tank. What happened is that the pressure will act around it. Okay, the pressure will be acting on its surface. And if you look closely into this arrow, you can actually see that the arrow on the top here is become much longer as you go down here. Okay, because the pressure at this point on the top is actually lower compared to down here below this part. Okay, if you draw, it will be shape. It's going to be like that. Okay, the pressure on the top will become larger, 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 and the largest one is down here. Okay, the very bottom of this particular ball. Okay, that is due to the H. Okay, because the height, right? Become the height is, if you look at the down here, it has the highest value of H, and therefore you will get the highest value of pressure. Okay, if you have the highest value of pressure, that can be translated into the much higher force because it is proportional. F is proportional to the pressure. Am I right? If you look to this, okay, that is one thing that you must understand. Okay, and this pressure on the surface is going to be like this. Okay, now if you look on this image here, this particular image on this side, what happened is that instead of having a ball, a shape of a ball, you have a square or a rectangle. Okay, then what happened is that you see that the pressure acting, let's say I put it P1, and here is P2, and here is P3, and down here is P4. What happened is that P1 is actually slightly lower than P2. Okay, because P1 is actually based on this particular height, H1. And if you go further down here, you see that the arrow is become longer and longer and longer, right? That is due to the fact that the height is increasing. The H is increasing. Similarly on this side. Okay. Similarly on the left and right. Okay. Therefore, P2 and P3 is actually the same, as long as the height is the same lah. Okay, because the height is changing, right, as it move down here from the top to the bottom. Okay, and one thing that you must remember is that P2 at any point, okay, at here, or down here, is always higher than P1. Okay, because P1 is basically above the location of P1 is actually above than the point of this and this one. Okay, so therefore P2 at any given point, let's say I expand this drawing, right? Okay, let me make it better. Okay. Okay. Here is actually P1. And from here further down until this point, this H, okay, this is your P2. P2. And this P2 is actually will increase. Okay, P2 is actually will increase. Okay, if let's say you say that a P2 at this point, which is on the same level as this particular top surface. Okay, now if let's say you want to measure, or you want to calculate P2 at this the first point, okay, then at that particular point, P2 is actually equal to P1, or P1 equal to P2 lah at this point. Okay, but if you move slightly downwards, now you can see that P2 is higher than P1. Further down, of course, it become much higher. Okay, I hope you understand that principle first. Okay, now how about P4 down here? Okay, P4. P4 is actually at this particular height. Okay, at this height, okay, at this point, this line down here. So what happens is that P4 is actually equal to the highest value of P2 or P3 lah, because P2 and P3 is the same. P4, sorry, P4 is actually equal to P2 if, only if, okay, your point of reference for the P2 is here, the lowest point, then it will be equal to this P4. Oh, sorry, P2 and P4 will be the same lah. Okay. Okay, and the value of P4 at this surface will be the same because it is on the same elevation. Similarly, like P1, because P1 is the value of H is the same, right? The height from this water level is the same. So the pressure at this point will be the same along this point. Similarly, at P4, it will have a constant value. But of course, the pressure at this point down here will be much higher to the pressure on top here. That is because the H is higher. Okay. You can put your metric number in the chat section. Okay. So far, any question before I proceed? Do you have any question before I proceed to the next part? Okay. I hope everybody can get that, get the idea on what is going on here. Okay. Okay. I will increase the size then. Okay. Now, if let's say you have the same water tank, but now the changes is that you have this particular slanting plane. Okay, you have a plane which is inclined, right, at certain angle. Sorry, at an angle of theta, for example, right? Okay. Then, then what happened here is that, okay, what happened is that the difference, if you are working with the previous example, okay, if let's say your okay, on the previous example, you have something like this, right? You don't have any, okay, you don't have any shapes like that, right? If let's say you have a shape like this, this is the gate or this is the opening, so that it will open and close. Okay, it can open and close, and it is hinged at point A, for example. Here is point A, and down here is point B, for example, right? So what happens that if this is the case, then how to actually solve this particular problem? If you would like to calculate how much forces acting on this particular, I call it door lah. It's easy, right? I call it this is a door, okay, which can open and close. Okay, so what happens is that you know that earlier I draw these particular shapes, and it is the pressure acting on this particular surface, right? Okay, but to make it much to make your life much easier, what you can do is that you just cut that out. Okay, you just you ignore this part. You don't have to draw it. Okay, you don't have to draw that part. You don't need to draw this part up till here. Okay, no need to draw that one. It's just enough if you can draw this part. Okay. Okay, now If you look into the shape, what's the shape is like that, right? Okay. Oh, come on. Okay, let me draw it again. It is actually a combination of a rectangle plus, sorry, a triangle plus a square or a rectangle, right? These particular shapes, this arrow. Okay, that's why when you want to calculate the pressure on this particular uh, uh, area, what you need to do is that uh, that is why you have this, what you call it, a HCG. Okay, HCG. HCG is actually uh, the distance from the top of this particular fluid up until the point of the line of sorry, the center of this particular door, the middle point of this particular door. If the door is, if you look from this side, you will see something like this, right? So if the door is shaped like this, then you just take half of this. It will be there, half of this height. Okay, so H is actually, okay, that's why I would like to relate from here to this point, because in some books they just make some shortcut. Okay, but the true story is that, okay, I took the long cut a little bit. The true story is actually you need to calculate the pressure or the force acting on this particular door based on this triangle plus this rectangle. So you have this plus this one. Okay, so what you can do is that the pressure P triangle plus P rectangle. Okay, okay, because I zoom it, I make it P1 plus P2 lah. Okay, because it's hard for me to draw it nicely. Okay, now what happened is that from here, P1, if you look these shapes, you are actually dealing with gamma H, right? Gamma H. Because due to the shapes of this, okay, that's why you divide by 2. It relates to this one. And here, basically, gamma H. Okay, this one could be, sorry, this one, okay, this particular H, I put it H2, H1 or H, okay, I put it as H2. H2 is actually from this point until point A, up until point A, okay? Measure until point A. It is your H2, okay? Normally in the book, they put it as H1, but in this particular example, I want to trick you a bit, okay? I want to change a bit, become H2 lah. So actually your H1 is the from the size of this particular door, the height. Okay, H1 is from here to here. This is your H1. Okay, you divide by 2 because you want to get the middle, uh, the center of it. Okay, if the shape of the door is not rectangular or square, if the shape is like that, okay, then I think you know how to find the centroid of this particular shape. It is 2/3 of the H if you are measuring from the top. Okay, if you are measuring from the top, it is 2/3 of the H. If you are measuring from the base, then it is 1/3 of the H. Okay, that is how it works. Because normally what you see or what you saw in the solution of any textbooks or the solution that I provide, okay, you will see this part, right? P total lah. P total equal to P1 plus P2. But then if you would like to calculate the pressure acting on this particular door, normally they put it as Fx, am I right? So Fx is equal to P total times area lah. Area is basically, let's say this is A, this is B, so A times B lah. Okay. So PT is actually this part. Normally, what in the example, they put it like this. So become H2 plus H1 over 2 times the A. You will see something like this in the books. Generally like this. Okay. I hope by now you understand what is HCG. Okay. This is your HCG. This one. This is your HCG. Okay. Later on, I will tell you what is HCP. Okay. HCP, sorry, HCP, P stand for pressure. Okay, center of pressure. CG is center of gravity. That's two different things. Okay. In any case, okay, in any case, in any condition, because of the physical, the physics of it, it is actually the center of pressure is always, okay, remember this one, is always below the center of gravity. Always. If let's say I'm running out of space now. Okay. Okay, I draw it over on this side. Okay. If let's say this is your CG location, this is your HCG, okay, because we already calculate based on the H2 and H1, like here, okay, HCG, okay, this is your HCG, and HCP, okay, HCP is actually a little bit down, okay, a bit a certain distance lah, further down. Okay, this is your HCP. Okay, HCP, center of pressure. And this gap here, the differences between HCP and HCG is normally we call it YCP. Okay, YCP is actually HCP minus HCG. Okay, this minus this one. Then you get this difference. Okay, what is YCP? YCP is actually, I forgot the formula. Okay, YCP is actually Can I remove this one? Because I need some space. Okay, YCP is actually IXX sine theta over HCG times A. Okay, HCG times A. Okay, now if you have a vertical, something like this, theta is equal to 90 degrees. Okay, if you have something like this, theta is actually 90 degrees. And sine of 90 degrees is equal to 1. Right? Okay. I hope you get what is actually happening here. Okay, from now, I think we are done on this part. Okay, we go back to this one. And now, okay, when you want to solve a problem from something like this, I think one of the question number 1 is similar to this, right? The principle is the same. If you understand the principle here, then you will be able to understand the solution in the for the question number 1, number 2, and of course number 3 lah. Okay. The solution for assignment number 2 I have uploaded since last week, if I'm not mistaken, in the Putra Blast. You can get the solution for assignment number 2 in Putra Blast. Okay, but for now, I want you to focus on this. Okay, okay. Now, if you want to solve a problem which is generally having something like this, okay, what happens that we for this problem, normally we want to calculate how much the forces acting on this particular door, okay, door AB, okay, this particular door AB. Okay, now if we want to solve this problem, normally we resolve this into the vertical force and also the horizontal force. Okay, what do we have in the vertical force? Okay, in the vertical force is actually summation of vertical force equal to 0. What you have is FV let me FV minus because Fy is going down, right? FV minus Fy. FV is actually this one, FV. This is your FH, V. Okay. So FV minus Fy, then again minus W, because this particular water is on this surface, is acting on this particular surface. Okay. Fy is actually only this. Okay, can you imagine that one? This is Fy. And W down here is actually this pipe down here. Okay. So minus W, and that is equal to 0. Okay. Later on, this is how it works. Okay. This is for the forces in the vertical component. Then how about the forces in the horizontal component? Okay. On the horizontal component, what you have is summation of force in the horizontal, then is equal to 0. Okay, and Why is equal to 0? Because this door is not moving, right? Okay. If the door is moving, then you need to deal with the motion, and that is you have MA lah, okay, or I omega in some cases. Okay, it is equal to 0 because this is a static problem. We are learning about the fluid static. Okay. Okay, now FH. Okay, FH is to the left. If let's say to the left is your negative, then put negative, no problem. If to the right is your positive, then Fx is your positive lah. Plus Fx equal to 0. No problem. Because later on, if you move this guy here to the right, then what happened is Fx equal to Fh, right? So no problem. Okay. This is the concept on how to resolve this problem. Okay. And let we zoom out a little bit. Okay. If let's say you want to compare from these shapes compared to this curved surface, okay, on the left we have a curve. It is only a flat plane, okay, and this one is curved. The only difference actually when you want to solve this particular problem is that when you want to calculate the value of W. Okay, when you want to calculate the value of W. Okay, W on this part is actually W is the weight, force lah. Okay, weight. Okay, weight and force is the same lah. Okay, unit is the same, Newton or pound. Okay, so W is going downwards here. Okay, now you have to deal with gamma. Okay, then you need to let me see, just a second. Okay, you need to deal with the gamma. If it is a water, so you need to gamma water. If you have a different fluid, then you need to multiply by the specific gravity or SG of that particular fluid lah. I hope you still remember that part. Okay, now we consider this is as a water, so you have gamma times the volume. Okay, volume of these shapes. If you can see, if I try to redraw, the shape would be, it is quite hard for me to draw it properly. Okay, it's gonna be that. Okay, it's gonna be like the shapes more or less like this lah. My drawing is not that good. Something like this. Okay, the volume of this particular pipe. Okay, so the volume of this, I think you know how to calculate. I don't have to explain to you. I think you have learned it many times since you were in high school. Okay, it's just half base times height, right? Or sorry, base times height times the depth. Okay, times the depth of it. DE. So I don't know. I might put it wrongly. Okay, here. But anyway, that is the things. Okay. Okay. Oops. Where were we? Okay. 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 This is this is actually these shapes. And here is actually based on these particular shapes lah. Okay, gamma water times the volume. Okay, volume of this pipe. Volume of that pipe is actually, it is from a complete circle, right? So you only take 1/4 of that. So that is equal to pi r square. Then because you only take a quarter of it, then you multiply by, or you divide by 4 lah, right? Okay, then you multiply by the length of it, or the depth of it, the depth or the length lah. Okay, then you get this value, right? That's the only difference if you are dealing with this and this one, because that is due to the shapes. If let's say you have the shape is very complex, something like that, okay, then what you need to do is that you can also simplify into this formulation. Okay, you can do that. It is your forces on this part, this one, and you only deal with whatever volume or the weight of water on this part. Okay, in this particular part, regardless of the shape of here. Okay, this shape here will only change the value of W. Okay, this one or that one. Okay, whatever shapes. Okay, now, okay, between these two up here, compare with this part down here. Oh, sorry. Between this one and this one, you see this one and this. Okay, what happened is that on this part, the weight of water is not acting on the door. See? Okay. Fx is still the same. When you want to calculate the Fx, is still the same, like what I've been shown here. Fx is equal to, the horizontal force is like this. Okay, it's the same for this guy here. Okay, you can refer to this. However, for the y component, okay, y component, you basically you didn't calculate from the top, but instead you calculate from the direction for Fy, you calculate from down here. Okay, that's the only difference. Okay, like here from the top, right? Down on this particular example from below. Okay, so what happens if you do calculate from below, then because W is always pointing downwards, right? So summation of vertical force would be like this. Okay, I think I missed something here. Yeah, actually you need to have FV. So this is your FH, and down here is your FV. If FV is pointing downwards, therefore minus FV should be here, right? Okay, I forgot to put this one. So basically FV is equal to Fy minus W. Okay. Yeah, this is the correct one. Okay. Similarly, on this part, okay, this one, is actually you only change the shapes, right? This one and this one, you only change the shapes. You just basically you need to calculate the new value of volume. Only the volume will change. Okay. So to simplify this one, basically you can do something like this lah. Volume 1, which is shape of this. Okay, this one. This is your this, and then you calculate another one, which is let me remove this. Okay, this part. Okay, this. Sorry, this part down here. This is your which is shape of that one. So what you need to do is the volume is equal to the volume 1 minus volume 2. Okay. How to calculate this? I don't want to tell you. I think you know how to do it, right? That's very simple stuff to do. Okay. This one is actually down here. What you have down here is only the differences is only the shapes. Here you have a long plate, okay, plane or plate. Here you have a curved surface. That's the only differences. So again, what's changing or what you need to deal here, or what are the item that will change from this example here compared to this one is that the W. Okay. How to calculate the W? Basically the volume lah, right? Okay, volume. And down here is actually a similar example compared to this one and this one. The same thing actually. This, and this. Okay, these three are the same. Okay. I hope you will get something today. You understand something. Therefore, you can straight away look into this the question assignment. Okay, solution for assignment number 2. This is in your Putra Blast, so you can get it from there. Okay, the solution. If you understand what I have explained just now, okay, then you will, I'm sure that you should be able to fully appreciate what is being discussed here. Okay. One thing that I would like to highlight is that for question number 1 and question number 3, okay, when you want to calculate the summation of moment, in this case, summation of moment at point B, okay, YCG minus YCP. Okay, YCG minus YCP. YCG. Actually, this minus. And the other example is that you use plus. Okay, in this particular example, you use plus sign. Okay, why is that? The other one is minus, this one is pluses. Okay, this one, see, plus, right? That is due to the distance. Okay, the moment arm. Okay, moment arm from where the forces is acting. Okay, don't be confused later on. If you go through this example, and if you have further question on this particular example, you can refer to me. Okay, or if you find some errors, you can also let me know.